Hi everyone, this is Miss Kaplan, and this video is on key features of quadratic functions. We're going to start by talking about positive and negative intervals. It's important that you always describe this in terms of x values. So to look at the positive and negative parts of a parabola, you're looking for the parts above the x-axis for positive or below the x-axis for negative. Let's block out below so we can just look at the positive portion. I'm going to leave the block down a little bit so you can see the numbers. The positive portion of this graph is shown in green. It is above the x-axis. The parts that are green go from, in terms of x now, from negative infinity, and they stop here at -1. So positive from negative infinity, and it stops at -1. And there's another part that's positive. So we're going to use the union symbol. And from 1 to positive infinity. Notice I've used round brackets here to indicate that it doesn't include that end number. Positive infinity is to the right, negative infinity is to the left. Now I want the negative interval, so I'm going to move my shade over the positive part. Just the negative part is showing now, the part below the x-axis, and you can see it in red on this graph. My negative interval goes from -1 to +1. And so we write that using interval notation from -1 to +1. Be careful, this is interval notation. This is not an ordered pair. It is not a point on the graph. It is a section of the graph, an interval going from -1 to +1. For the next one, you see that we're looking at a parabola that is upside down, right? And so when we're looking at the positive portion, we're still looking at what's above the x-axis, and we're describing it in terms of the x values. So between -1 and 1, can you see it? Between -1 and +1 is where the graph is above the x-axis. All right, so positive is above the x-axis, and negative is below. And we always give this in terms of x values. The positive portion goes from -1 to +1. Negative portion, the part shown in red here, goes from negative infinity, stops at -1, and then there's a whole other section. So again, we're using union from +1 all the way to positive infinity. The mistake most students make with these is to start to give y values. You see those arrows sort of pointing up or down, and your instinct is to give y, but you're only giving the x values in these intervals. So you're just describing the part above the graph in terms of x for positive and below the x-axis for negative. Next, let's look at intervals of increase and decrease. And again, we're going to give this in terms of x values. So this is like describing the hill. Are you going downhill or uphill? You always start on the left when we're describing an interval. So again, I'm going to use this to cover the part that's I'm not looking at right now. This is the downhill part of this parabola. So it's an interval of decrease. So where is it decreasing? You give your x values, interval notation, from negative infinity, and it stops at the x value here, right, is 0. So from negative infinity to 0, we are going downhill. We are decreasing. For the interval of increase, I'll move my shade. Increase, I'm going uphill from left to right. The x value is 0. That's where it turns, so that number is always going to match. This is where we started going uphill. Remember, you're not going up to positive infinity. You are going to the right. X is what we're looking at. And while it is going up faster than it's going right, it is going towards the right to infinity. Okay, and if you look at a downward facing parabola, the interval of decrease, or let's start with increase here, because we're increasing first. It doesn't matter which one you start with. The interval of increase this time is from negative infinity to 0. Remember, x values, I keep saying it because it's that important and it's that common that you start to look at the y value by accident, so be careful. And the interval of decrease, where the graph is going downhill, red arrows going down, from where x is 0 to positive infinity. This whole side of the graph, the parabola is going down or decreasing from 0 to positive infinity. Now, these two parabolas happen to be centered on the y-axis. That will not always be the case, but wherever it is, these numbers will match because that's the shape of a U. It's going down, and then there's a point, the vertex, where it turns and starts going up, or the other way around. On this slide, we're going to look at all of the different features of a quadratic function. And so we did this with exponentials. You're familiar with these already. I reviewed the ones that I thought you might be a little shaky on. This is the graph of f of x equals x squared minus 6x plus 5. You're going to do one like this yourself in a minute, so pay close attention. And on the next slide, you'll pause, do the work, and then continue on to check. So you're finding the vertex and telling whether it's a maximum or minimum. The vertex is the turning point. Notice we're going downhill, and then right here, in this case, it's a bottom, a minimum, right? And it starts going up. So that is always your turning point, the vertex. The vertex is the point 3, negative 4. The domain for a quadratic function will always be negative infinity to positive infinity unless it is a word problem and the context limits that domain. Just like with exponential functions. The range depends on the function. So for this, the range is all the possible y values where this graph exists. So if you take a look, you'll notice that my range, the only place the graph exists is from, range is y, from negative 4 up. How far up? All the way. Those arrows keep going. So our range is described as the interval from negative 4, and square bracket, it includes -4 to positive infinity, because up, that doesn't stop, is positive infinity. The y-intercept, we don't see this on the graph. There is a y-intercept, and you can tell where it is because of the value of c. Remember, standard form for a quadratic, ax squared plus bx plus c. C is your y-intercept. Kind of tell. Because if this graph kept going, we'd be up here somewhere, and it appears to be that it would be 5. So your y-intercept in this case is 0, 5. And if they don't show it on the graph, you need to get it from the equation. It is your constant. The x-intercepts are 1, 0, and 5, 0. The intervals of increase and decrease it's decreasing until it gets here. Remember that we're giving x values, right? So the interval of decrease is from -infinity until we get here, which is 3. The interval of increase, increasing from here all the way. So this is 3 again. Remember I told you has to match. From 3 to positive infinity. We don't care how high or low it's going here. We're just looking at where it's increasing or decreasing. Positive and negative intervals. All right, we're going to look at the top part of the graph for the positive, and then we'll go to the bottom part of the graph for negative. It is positive from -infinity until we get here to positive 1. It is also positive from 5 to positive infinity, union 5 to positive infinity. So one of these is always going to have 2 parts to it because it's a U shape, and so it has to. The negative interval is the part below the x-axis. And in this case, that is from, remember you're looking at the x's, from 1 to 5. And so we describe that as from 1 to 5. Remember that this is an interval, not an ordered pair. The end behavior of this graph is that it is concave up. That means that it is opening up. Concave up is a term that you'll see a lot in testing, but it just means that it opens up instead of opening down. The axis of symmetry is the vertical line that passes through the vertex. Every point on this line has an x value of 3. Check it. The equation for this is x equals 3. All right, I want you to go to the next slide and try these on your own. Pause the video, answer the questions, and come back and continue when you're done. Okay, how did you do? Check your work. Be prepared to ask any questions that you have when we come back together in class. On the final slide, you'll see links for extra practice. Don't forget to write what you noticed and wondered for today.